Okay, so we're ready to go here. Oh, got to plug this in. Okay, is there anybody here who didn't get their test last time? I think Josh, you were you here? You got it? Okay. Okay, so we're going to do section 5 today. I have posted the review on the YouTube channel under reviews. It's a fairly long review, so I go into a lot of detail of what's on the test. Yes. You want to? So section 5, the topic is expected value, and basically what the expected value is, if you had a, well, let me give an example, my basketball example. If you have somebody who statistically has a 80% free throw chance, then the expected value would be that if they shot 10 free throws, they would make 8. That's the expected value. That's usually the value that has the highest probability of occurring, but somebody who has a historical 80% free throw shoot doesn't shoot 80% every time. So you can do it the short way, or you can actually figure out what the expected value is by looking at the probability of each particular possibility and multiplying the probability of each possibility by the value associated with each possibility. So shooting free throws, the value associated with making 8 free throws would be 8, and the value of making 7 free throws would be 7, and so forth. So let's look at the definition for expected value, the math definition. So the expected value, it says if a random variable x can have any of the values x sub 1, x sub 2, etc. So there are fixed values that this variable can have, and the corresponding probabilities of these values occurring are p of x of 1, p of x of 2, etc. So those are the probabilities associated with those values. Then the expected value is calculated as following. So the expected value is the value of the variable times the probability of getting that value plus the probability of another value multiplied by the probability of getting that other value. And you keep doing that, and you do it for all the particular possibilities you have. And then you add those products together and you get the expected value. So the example I'm going to use is basketball, and I'm going to use a simple example just because I don't want to have to do a bazillion calculations. So let's say that so this is the guy's statistics. The guy's free throw percentage is what am I going to use here? We'll say we're going to say it's 65%. So he's kind of an average free throw shooter. So that's his probability of success. The probability of failure is 0.35. And we're going to shoot three free throws. And what we're going to do is there's 4 options. Yes. This one here, that's the probability of failure. So that's the probability he's going to miss, which is equal to 1 minus the probability of success. So there are 4 options as far as scoring points is concerned. You can make 0 out of 3, which has the value associated with 0 out of 3 is 0. Doesn't get any points. The second option is 1 out of 3. The value there associated with that is 1. Let me add another page. So then we'd have 2 out of 3. That the value there is equal to 2. And the last one is he makes all 3 shots, 3 out of 3. So the value associated with that is 3 points. So this would be X. Using this definition of expected value, you have X1 times P of X1. So in this case, I have 4 possibilities. So this would be X1, this would be X2. So X1 is equal to 0. X2 is equal to 0. Is equal to 1. These are the values associated with each one of those. So I'm going to specifically say they are X, and then X of 3 is 2, and X of 3 is 3. So those are the values for the first part of the product. The next thing we have to do is figure out what the probability of each one of these happening, given that his average free throw percentage is 0.65. So the probability of getting 0 successes out of 3 trials is going to be equal to the combination of 3 things taken 0 at a time times the probability of success raised to the x power, which is 0, the probability of failure to the n minus x, which is 3. So that's the formula. We'll go back, we'll write out all the formulas, and then we'll go back and calculate them. Actually calculate the corresponding probabilities. Okay, in the second case, the probability of getting 1 out of 3 is you take a combination of 3 things taken 1 at a time. You take the probability of success raised to the first power, the probability of failure raised to the second power. So we increase this by 1, decrease that by 1. The probability of 2 out of 3 so x is 2, n is 3, so it's 3 things taken 2 at a time. You take the probability of success raised to the x power, which is 2, and the probability of failure, which is the difference between these two, which is 1. And then finally, the probability of him making 3 out of 3 is a combination of 3 things taken 3 at a time, the probability of success to the third power, which is x again, and the probability of failure, which is 0.35 raised to the difference between those two numbers. So those are all the different calculations. I'm just going to go ahead and do them. So the first one, anything taken 0 at a time or anything taken the same number is going to be 1. So in this case, this will be 1, and this will be 1. And anything raised to the 0 power is 1. So that's 1, and that's 1. So you can remember those 2 things. Okay, so the first calculation ends up just being 0.35 to the third power, which I get to be 0.0429. And the second one, anything taken 1 at a time, is just the number that's at the beginning, so that's going to be 3. So I'll take 3 times 0.65 times 0.35 squared. So that ends up being 0.2389. If this number is always, if 1 less than this, then it's the value here. So this is 3 again. So we're going to take, it'll be 3 times 0.65 squared times 0.35, which is 0.4436. And the final one, this is 1. So we take 1 times 0.65 to the third power, and we get 0.2746. So those are all the probabilities, and the most likely answer is 2 out of 3, which is 66%, which is close to his average. Not exactly his average, but that's the most likely outcome is his long-term average for this short-term amount. Okay, so now how do you figure out the expected value? Well, there are two ways of figuring out the expected value. The simple way, the expected value of x, one way is to take his probability of success, which is 0.65, and multiply by the number of trials. So if the number of trials was 100, he would have 65 successes on average. Now if he only has 3 trials, then he's not going to have an integer. It's going to be something else, pretty close to an integer. But the expected value will be 1.95. The expected value doesn't have to be an integer, even though in reality it has to be an integer because he can only shoot an integer number of free throws. That just means on average he's going to make a little less than 2 out of 3 on average. So that's one way. The other way is to use this probability formula. So what you do is you take the expected value of the first case, which was 0, times the probability of making 0, which is 0.0429. Then you add the value of the second situation where he made 1 free throw times the probability of making, and which is 0.2389. Then we take the third option, which is making 2 out of 3, multiplied by the value, which is 2, multiplied by the probability. And then finally, the final possibility, which is making all 3, multiplied by the probability of making all 3. And if you plug those into your calculator, you get 0 times 0.0429, which is 0. Then you get 1 times 0.2389 plus 2 times 0.4436 plus 3 times 0.2746, and you get 1.9. I must have copied something wrong here because this is not coming out. It's still coming out close. Well, no, it is actually. So it's 1.9499. So that's the exact expected value. That's slightly off by 1/10,000. It's off 0.0001. So it's essentially equal to that. It's just the number of decimals that I carried out in that calculation of probability. So that's the other way of calculating expected value. So you might say, well, why would you do this if you can do that? Well, there are cases where we can't do that, so we have to do that. We have to do it the longer way. Okay, so this was another example. You don't have to copy this down, but this was a little bit longer example I did in the previous year where we had not 5 free throws with this percentage, and I had to look at 6 cases. I had to look at case of making 0, 1, 2, 3, 4, and 5. Each of those had corresponding values. You can come up with the probabilities of each of those, and then you can multiply those probabilities by the values. So if you add all the probabilities together, you get 1. But if you take the value... Okay, so your attendance question here. And I'm just going to turn the sound off there. Okay, so this is a simple one. You don't have to look too much up. So what is 5 plus 4 equal to? Okay, put that in your response. Times the probability, you get the expected value. So same kind of deal. So what we're going to do is we're just going to work through some problems here that are not basketball problems, but they are they're game problems. So let me put this on one page so you can see it. So this is problem number 9. So we have a game involving the tossing of 3 fair coins, and it pays 10 cents. So what you do is to play the game, you could put in 5 cents. And then you roll 3 coins, or 1 coin 3 times. And if you get 3 heads, you get 10 cents back, so you get more back than you put in. If you get 2 heads, then you get 5 cents, get back what you paid in. If you get 1 head, you only get 3 cents, and if you get 0 heads, you don't get any money back at all. So the question is 5 cents a fair price to pay to play this game? What does that mean? What does fair price mean? Well, fair price would mean that your expected value is the same as the amount that you paid. So over the long run, you would win as much as you lose. Well, yeah, it wouldn't be much of a game. But yeah, that's right. Yeah. Well, nobody wants to play a fair game. So, casinos in the long run, they're going to make money. The games are designed for the casino to win. There's a small subset that wins, and they get all excited and go out and tell all their friends that they won and lucky, and all the ones that lose just go home and sulk, and you never hear about that. So, there's this false sense that you can beat the house, but over the long run, you can't beat the house, and so it's not a fair game. So in this case, if you're playing the game, you would like it to be unfair in your favor, but that's not going to happen. A fair game would be, instead of a 50-50, it would be 0-100. Is that you would pay, and everybody paying $1, 100 people would play, and then the winner would get $100. And nobody would make any money, so there would be no point in doing the game, except it's kind of like an office pool. If you say it's time for basketball tournaments, you have an office pool and everybody puts money in, and the one who wins gets all the money. That's a fair game. But that's because nobody's trying to make a living off of playing the game, or nobody's trying to get money for a charity. So most games don't have a fair price. One of the questions is the price, it's probably not fair, but is it so much slanted towards the people who are running the game that it's basically, you might as well just give them your money? And I guess I didn't win the lottery last night. I decided the other day to play lottery. I bought 1 ticket. I was sitting there, it was Valentine's Day, which I guess was yesterday. Was it yesterday or the day before yesterday? When was that? Day before yesterday. And I was getting some gas, and I look up and I see $300 million. And I go, it must be a sign. It was a sign. It was literally a sign. And I said, I'm going to buy 1 lottery ticket. So I bought it. And I didn't see any TV trucks out in front of the place where I bought the thing. So I don't even have to bother looking at it. Okay. So anyway, this is the game. So what we do is we need to figure out what the expected value is. So we have the values for each situation. What we need to do is figure out the probability. So we've got we need the probability of 3 heads. We need the probability of 2 heads. We need the probability of 1 head. And we need the probability of 0 heads. And we've done this problem before. You can do it using binomial probability, so why don't we just do that? So it's a binomial situation because it's a fair coin. It says right there fair, so that means it's 50% chance probability of winning and losing. So in this case, you take 3 things, 3 at a time, and the probability of success is 0.5. You raise that to this power, the 3rd power. The probability of failure raised to the 0 power. For 2 heads, you take 3 things, 2 at a time. Probability of success to the 2nd power. These 2 match. The difference between these 2 is that exponent. These always add up to the same number, 3, 3, etc., etc. This one's 3 things taken 1 at a time. 0.5 probability of success raised to the 1st power. Probability of failure raised to the 2nd power. And the 3rd one is going to be 3 things taken 0 at a time, multiplied by the probability of success raised to the 0 power, probability of failure raised to the 3rd power. And if you do the calculations, you'll get 0.125, 0.375, 0.375, and 0.0125. 0.125. So those are the four possibilities. If you add these four numbers together, you get 1. One thing about coin problems is that this second part is always the same, because you've got 0.5 cubed times 1, you've got 0.5 squared times 0.5, which is 0.5 cubed. You've got 0.5 to the first power times 0.5 to the second power, which is 0.5 cubed. And over here you've got 0.5 to the 0 power, which is 1 times 0.5. So the only thing that changes is the first number. This second part is always 0.5 cubed, which is 0.125. So you get 0.125 times 1, 0.125 times 3, 0.125 times 3, 0.125 times 1. So that's how those numbers come about. So the expected value now, we've got the value. So let me just write the values in here. This would be x1 would be equal to 3, x2 would be equal to, no, it's not actually, it's equal to 10. So the value of getting 3 heads is 10. The value of getting 2 heads is 5. The value of getting 1 head is 3. And the value of getting 0 heads is 0. So now we just take this times that, plus this times that, plus that times that, etc. So the expected value of this game is going to be 10 times 0.125 plus 5 times 0.375 plus 5, or 3, plus 3 times 0.375 plus 0 times 0.125. And if you plug that in your calculator, you will get a number. And notice there's no shortcut way of figuring out. Well, there is actually, and I'll show you what that is, but it's, and you get 4.25. So that's the expected winnings, 4.25 cents. On average, you're going to make that much, but you're going to spend 5 cents. So it's not considered a fair price. But you do have that 1 in 8 chance of winning 10 cents, actually making money. So if you like risk, it's not a super risky game. I mean, it's pretty close to the expected value is close to the price to pay to play the game. Okay, next couple are going to be, these are similar to what I put on the test as far as what I expect you to know about this. So these are games which we know are supposed to be unfair because you're trying to raise money for something. Oh, I was going to tell you how you could figure out the answer here otherwise. It's kind of like a business question. How much money do I take in and how much money do I give out? So let's say we take 8, we look at the 8 possibilities. And we assume that we get every one of the 8, 1 here, 3 here, 3 here, 1 there. So let's say we have 8 plays. We play the game 8 times. And we get them exactly equal to the theoretical probability of the things. So if you put your, I'll say income, that's how much you're making by playing the game, is going to be 10. You get 10 cents for this one, which is 1. You only get 1 out of the 8 happens, you get 10 cents. 3 out of the 8, you get 5 cents. So you take 3 times 5. And then here you would have, there are 3 cases where you get 1 head. So you get 3, and you get 3 cents back for that. And then finally, there's 1 case where you get nothing. So if you add all that together, you get 10 plus 15, which is 25, 25 plus 9, which is 34. So that is how much I get by playing the game on average. My cost is, there are 8 games, and each one costs 5 cents. So I spend 40 cents. So you can see I get less back on average so my net, if I could, well, that's not really, I guess I'll call this revenue instead. Revenue. So my profit on average, my profit total is going to be 34 minus 40, which is negative 6. So each time for playing 8 times, I lose 6 cents. Actually, if I take 40, let me make sure if I'm doing this right here. Oh, if I take 34, the revenue, and divide by the number of times I play, so 34 divided by 8 is 4.25. So that's the other way of coming to the expected value for my winnings, is by taking the total revenue that I would get for playing 8 times and divide by the number of times I play, which is 8, and that gives me the same number. So that would be another way of getting the same answer. Not that I want you to do it that way, but okay, so here's the next problem. So we have a raffle, and we sell 600 tickets for $120 each. That's a little expensive for my taste. I'm good at $2, but any more than about $5 I'm not going to do. So it says, what is the expected net winnings of a person buying one of the tickets? So the way we do that is we look at the probability of winning and how much money you get for winning, and the probability of losing and how much money you spend for losing, and you add those two together like an expected value calculation, and you get a value which is essentially how much each person wins or loses on average. Not the one person, but everybody on average. So let's just do the calculation. We'll explain what it means once we get it. So this is problem 13 in your book. And it says expected net winnings. So we'll say expected net winnings. So to calculate the expected net winnings, you take the probability of winning times the value of winning plus the probability of losing times the value of losing. So the probability of winning, well, there's 600 tickets. There's one winner. So the probability of winning is just the number of winners divided by the total number of tickets sold. So that's the first thing, probability. The value of winning is you get a car. Now the probability of losing is 1 minus the probability of winning, which would be 590. So we have 599 losers and 1 winner, Donald Trump, everybody else. Everybody else is losers. Okay, so the value of losing is you lose $120 per person. What does that mean? Huh? Yeah. Now there's one error I have. I've left a space in there. So if you win $36,000. So why did I leave a space in there? Right, yeah. So to play, everybody pays $120. So even the winner doesn't win $36,000 net. They only win $36,000 minus 120. So let's do the calc. 36,000 minus 120 is 35,880. So that's his net winnings. And then you get 599 over 600. Probability of losing. The cost of losing is paying your money for the game, and then you do the calculation. And I did something wrong again. I did this yesterday. I messed up on my entry in my calculator. I always leave off one of the numbers. So the expected net winnings is minus $60 per person. So that's the answer for the first one. So on average, everybody loses $60. The reality is that 599 people lose $120 and one person wins $35,880. So the second question is, what is the total profit for the foundation, assuming they had to purchase the car? So there's two ways of doing that. One is to use the expected net loss per person, because what is it they say? One man's trash is another man's treasure, or somebody's loss is another person's gain. So in this case, the money that the players lose, they don't burn it. It goes to the profit. So we could say that the expected net earnings, we'll say the expected net earnings, I gotta remember how to spell earnings. Earnings per person for the foundation equals plus $60 per person. And then to find the profit, we'll say just the total profit is just equal to the profit per person times the number of people. So number of people. So what you get is you get $60 per person times 600 people, and that's $36,000. So that's the net profit, using the net loss, the net winnings per person being the net earnings for the foundation. The other way is to look at it from a global standpoint. How much did I spend on the raffle? How much did I get back from the raffle? So that's the second way of doing it. I want you to be able to do it both ways if I ask you this question. So the second way would be to say, we'll say net profit equals revenue minus cost for the foundation. So the revenue is going to be equal to 600 people times $150 per person. Was it $120 per person? And the cost is a $36,000 car. So if you multiply the first two numbers together, you get $72,000. You subtract the cost of the car. That means the foundation is going to make $36,000, which is exactly what we got previously. So one way is looking at results per person, and the other way is just to look at the whole thing. Now, if you didn't have to pay for the car, then all the money that comes in, the $72,000, is going to be free. That's why you try to get people to donate stuff for raffles so that you make more money. If you have to buy something, if you get stuff donated, you're always going to make money. If you have to actually pay for it, then it gets a little more scary. So I'm sharing with you a text that I got this morning. This is a little sidelight. My daughter. So this is my younger daughter who has the boy who's almost 2. Says, when I got Xander out of bed this morning, he patted my back and said, "You're a good boy, Mommy." And that comes from the mother saying to him all the time, "Xander, you're a good boy. You're a good boy." So of course, he doesn't understand the the concept. I guess he thinks probably boy is just him or just a person. Because when they're driving home from work, she'll say something about something he did. You were a good boy, weren't you, Xander? Yes, I was a good boy. So mommy's a good boy too. That's cute. Okay. So to answer the questions and the problem here, the expected net winnings per person were negative $60. The total profit, assuming they had to purchase the car, was $36,000. And the net total profit if the car was donated is just the total amount of tickets that were sold, which was $72,000. Okay. So let's look at another one, kind of the same way. 5,000 raffle tickets are sold. There's one first prize of $1,000. 2 second prizes of $500 each, and 3 third prizes of $100 each will be awarded, with all winners selected randomly. If you purchase 1 ticket, what are your expected gross winnings? If you purchase 10 tickets, what are your expected gross winnings? If the tickets were sold for $1 each, how much profit goes to the raffle sponsor? So notice originally they don't give you any information about how much the tickets are sold, and so the gross winnings are basically what you're going to get back on average per person. It's going to be a positive number. And then if it was a fair game, then you would set your price equal to that value. If you want to make some money, then you make your price higher than that value so that the net winnings would be negative for the players, therefore positive for you. So all we have to do here is we have to figure out, to calculate gross winnings, we don't have to subtract the cost of the tickets. All we have to do is take the probability of each prize multiplied by the value of each prize and add them together. So we're going to have 3 terms. We're going to have one term associated with $1,000. We're going to have a term associated with $500. It's two out of the 5,000 are going to get $500. And then the third case is going to be 3 people to win $100. So if we want to look at expected net or gross winnings, so all we have to do is take the probability of winning $1,000 multiplied by 1,000 plus the probability of winning 500 times the 500, probability of winning 500 plus 500 times the probability plus the probability of winning $100 times the value. So the question is, what are these probabilities? Well, the first one's easy. It's 1. There's 1 winner out of 5,000. So what do you think the second probability would be? What's that? Is it 1 or 2 out of 5,000? So the 2 second prizes, each $500. So you could kind of think, so yeah, you might say it's 1 out of 1,000 times, or 1 out of 5,000 times 1,000, because it's the total value is worth 1,000, but it's really and you give it the same number, but the probability of getting a $500 prize is 2 out of 5,000 because you have 2 winners, 2 tickets. And then the third case is you have 3 people out of 5,000 that win $100. So you just add those together. So you get 1,000 divided by 5,000 plus 2 divided by 5,000 times 500 plus 3 divided by 5,000 times 100. And so you would get $0.46 per person, or per ticket. I guess I could say per ticket, because somebody could buy more than one ticket. So that's the answer for the first part. The gross winnings per ticket are 46 cents. So if you purchase 10 tickets, your expected gross winnings is going to be 10 times that. It's going to be $4.60. Not per ticket, but per 10 tickets. I guess I could say 10 tickets. Now, the final one says, if tickets were sold for $1 each, how much profit goes to the raffle sponsor? So there's really two questions in that. You figure out what is the profit per ticket, and then you multiply by the number of tickets. And that will give you the total profit. So don't just subtract, you don't subtract 46 cents from $1 and it's 54 cents, and that's the answer, because that's not what they're asking. They're asking for the total, how much profit goes to the raffle sponsor. And it doesn't say per person, it says just, it doesn't, so I'm assuming that it means the total amount. So part C is, you would say, net amount to sponsor per ticket is going to be equal to $1 minus the amount that I pay out per ticket, which is $0.46, which is $0.54 per ticket. And so the total profit is going to be equal to 5,000 tickets times $0.54 per ticket. And when you multiply those together, you get 5,000 times 0.54, which is $2,700. So that's the total profit. So it's almost like a, as I say, it's almost like a 50-50 kind of, it's like playing 50-50. Has anybody ever won a 50-50? Has anybody ever played a 50-50? You can't win if you don't play, right? Nobody. I usually don't play them. You go to a basketball game and they're selling tickets. The only time I buy them is if. So I'm doing an experiment this time. I'm asking you two questions. So the other one was some additional problems. So let's do a subtraction problem. 25 minus 3 equals what number? So put that also in your response. The person selling them is somebody I know, and I'd be nice about it, but otherwise I don't do it. Okay, let's see what we got here. Okay, so here's another one. In a certain California city, projections for the next year that there's a 20% chance that electronics jobs will increase by 200, a 50% chance that they will increase by 300, and a 30% chance they will decrease by 800. What is the expected change in the number of electronics jobs in that city in the next year? So I'm going to let you see if you can figure that one out based on what we've done previously. So these are the probabilities. If you add 0.2 plus 0.5 plus 0.3, you get 1. So those are the three possibilities. You've got values. So you have the probabilities, you have the values. Just multiply the probabilities by the values and then add them up and make sure you use the correct sign. Increase is positive and decrease would be negative. So for you guys online, let's see what you can come up with an answer. So there's I'm going to put the other one, the previous one, on the screen here so you can kind of look at it and think about it. And then you can give me an answer. So I think everybody's here now. So we are having the test next Tuesday. I thought about next Thursday, but you guys are ahead enough that Tuesdays is going to work out okay. So just take your probabilities multiplied by your values, add them together, and that will give you your, somebody's working in the economic development office, and you have to give her a report because they have to figure out what the expected tax base is for the. That's actually what they do. I think the revenues for Virginia were down for some reason from their projections. Where the heck do they get their projections from? So you look at your sources of revenue and you think about how things like personal property tax. That's probably pretty predictable. You could estimate how many new cars you think are going to be sold, so that you have more expensive cars, so you have more tax. And then you have income tax, which that should be pretty predictable. If you know, unless there's going to be some big recession where people are going to lose their jobs, that seems like that'd be pretty predictable. Then you've got sales tax. I think that was the one that was highly unpredictable. We'll ask you that question. Why do you think that is? Okay, let's see if anybody in line's got an answer yet. Not yet. Okay, Harmony's there. Oh, good, Harmony's there. She'll give me an answer. Okay, so let's see what we get. So we have a 20% probability that we'll have an increase of 200 jobs. We have a 50% probability that we'll have an increase of 300 jobs. And we'll have a 30% probability that we'll have a decrease of 800 jobs. And when we put those into our calculator, 0.2 times 200 plus 0.5 times 300 plus 0.3 times negative 800, we get negative 50, which is what Harmony got. So the expected value is that they're going to lose 50 people being employed in electronics jobs over the next year. And the last problem in this section is problems 29, 30, and 31. So we are a concert promoter. Let me put this on one page. And we're trying to decide whether we want to buy some insurance for our concert. So it's like the Floyd Fest, it seems like, or the West Virginia State Fair. It always rains every year for the West Virginia State Fair. And yes, pardon me. Oh, what kind of concert? It can be anything what would you like it to be? What is your favorite group or individual? What's that? Skrillex? No, I never heard of them. Katy Perry. So it's Cyrillics? Is that what you said? I don't know. Okay, so the promoter, he expects $100,000 for revenue unless it rains, which reduces the profit down to $30,000. So nobody wants to go to a concert. Not many people want to go to a concert where there's outdoor concert raining. You look at the probability of rain based on 100 years of data for that particular day, and you find out the probability of rain is 20%. Now it says for a premium of $25,000, David can purchase insurance coverage that would pay him $100,000 in the case of rain. So not only does he make $30,000, he gets $100,000 insurance, so he actually makes more if it rains than if it doesn't rain. But it costs him money whether it rains or it doesn't rain. So you got to make that decision whether it's worth him doing it or not. Now ultimately, the guy selling the insurance is probably, he's probably done the calculation, and over the long run of insuring constants, he's going to make money. The reason you would buy insurance is so that you don't have a really low year, and then you don't have enough money to pay the new acts for next year in advance if you have to pay in advance. So all the business things of why you might have insurance other than trying to make more money, right? So it says find the expected net profit when insurance is purchased. Second question is find the expected net profit when insurance is not purchased based on the expected values, which is David's wiser choice. So you would think the wiser choice in the long run, if he has enough money saved up to take into contingencies, is whatever one has the highest expected value. So what we have to do is we've got two probabilities here. We've got the probability of raining or not raining. So we'll say the probability of rain is 0.2. The probability of no rain is 0.8. And the values associated with this, for the first case, if he buys insurance, so if he buys insurance, he's going to make $30,000. He gets $100,000 insurance, but it costs him $25,000 every year for that insurance. So there's three parts to that. You don't just say, you can't take one number. You take the profit plus the insurance minus the cost of insurance. So the same thing applies for no rain. If he has no rain, he gets $100,000, but he does have to pay $25,000 for insurance for each one of those cases. So these are the values associated with the certain probabilities. So part A, the way you do it is you take the probability of rain times the value, which in this case would be $105,000. If you do the math, you've got 30 minus 25, which is 5, plus 100 is 105. And then you take the probability of it not raining times the value associated with not raining. So we do that calculation, see what it is. That's part A. 0.2 times 105 plus 0.8 times 75,000, and we get 81,000. So that's the expected profit per year. In the case of B, what happens is probabilities stay the same, but the value associated with rain is just $30,000. He doesn't buy insurance, so he doesn't have that taken off, but if he doesn't get any kind of reward if it does rain. And then you have no rain. So in that case, you get $100,000. So it's a simpler calculation. So you take the probability of rain times the value of rain, probability of not raining times the value of not raining, and we get 30,000 times 0.2 plus 0.8 times 100,000, and we get $86,000. So the answer, which is the wiser choice, just from an expected value standpoint, it would be, the wiser choice would be to not buy the insurance. It's kind of like when you have an old car, when do you decide to take it off collision? Because the value of the car is smaller than the amount that you would get for the insurance. You know, it's just there's a trade-off period. How many people don't have collision on their cars? So how many? Everybody else has collision. One thing is you have to have collision if you're still paying your car, because the insurance company wants, if they want to know if you have a car wreck that you can pay the bill. So the only time you don't, there's two things you don't worry about. One is if you you first have to pay your car off, so you have a pay. You're never going to have. So I have paid off my car, and secondly, if it's old enough, at some point you decide that you don't want to spend the extra insurance money on collision. You're just going to keep that and hope you don't have an accident, or if you do have an accident, you'd still come out ahead anyway. So don't always assume that you should. If you ever pay after your car, think about that. There's a decision. It's not an easy decision. I mean, it's not like a formula. You stick the number in. But typically, if your car is maybe like older than 10 years old and you paid your car off, then you probably should just have comprehensive and liability, but just get rid of the collision. So my car is 17 years old, so it's definitely too old for, I mean, you could still pay it, but it's not worth it. So, but the question is, why might he still buy insurance? If the net amount, the expected value, well, the other question is, so that's why the guy's selling insurance. The guy's selling insurance not to be a nice guy. He's selling it to make some money. So on average, every year, he's going to make the difference. He's going to make $5,000 a year, something like that. I think that it is. You know, the insurance guy's going to make some money. That's why he's in business. So there's got to be a reason why you buy insurance. Well, the reason is because if you had rain 2 years in a row, that doesn't happen very often, but 2 years in a row and you only get $30,000, then that may not be enough for you to pay people to develop, you know, call the people up and book the bands and pay the venue in advance and all the other things you've got to do in advance. So you have to take out a loan, and then if you have another rainy year, then you're out of business. So even though he is making less money on average, it might be a better business decision. So there's the homework for section 5. So that will be due next Tuesday since we have a test.